Hi there, today I want to look at electric toothbrushes. In the main you pay megabucks for one like this, which would have at the end a coil of wire. You'd slip it onto a thing that plugs into the mains and it would charge up the battery. That then of course has a head on it which rotates and helps clean your teeth. On this particular one though, I've removed the innards and hopefully replace them if it works. No, it doesn't work. With a different battery. I've put in a larger, a larger cell into here. This is a lithium cell, which is quite a bit bigger than the normal one. If I plug it in and push the switch, it starts working, and press the other switch and it stops working. Unfortunately, we've had a disaster, because what's happened is by putting this end on here, this bit hasn't come out and therefore it's all fallen apart. So what do we have? Well, if we look in here, we have the gear wheel on the motor. On here we have another gear wheel, slightly larger, so it should go a little bit slower. Plugs into a little hole there, so that when the motor goes, that gear wheel goes round and round, and it has an eccentric on it. There's a joke there somewhere, but never mind. An eccentric, so it goes round and round, and this piece of rubber here then is going to connect onto the end of this little rod here. So as this goes backwards and forwards, that goes backwards and forwards, it makes the end rotate backwards and forwards, so that would go into somewhere like that, and hopefully we'll just plug onto the end and what? And therefore it will vibrate backwards and forwards. I must have it in the wrong place because I can't get it to work at the moment. But anyway, that's how it works. If we look inside the head, here we have a head. So here we have a head, and if we push a screwdriver or something into it, must have a screwdriver somewhere, push a screwdriver in and then rotate it backwards and forwards, we can see the head rotates backwards and forwards as I do this. That then has a simple mechanism up at the top. On the head is a little cutout there, and on the arm here there's the rod that goes up. If I can show this, you can see that rod going backwards and forwards. It's just a little round sphere on the end of it that goes backwards and forwards and moves the head backwards and forwards. So why am I looking at this? Well, these things seem to use batteries like nobody's business. These particular ones that operate on the mains and charge on the mains, they seem to cost megabucks, and there's lots of videos on the internet showing you how to replace the batteries. Whether they constantly charge the battery or not, I'm not too sure. I haven't looked at the electronics on that, but these things are a lot cheaper. I think they were about £6 or something like that, including cheapo batteries, and so therefore I tend to go for these. The mechanism seems to be very similar to the ones in the expensive jobs. The problem is to get the mechanism out, and if we have a look at one of the mechanisms. Here we have this. Then we find on it, it has a couple of sticky out bits, but they are firm, they won't push in. So to get it out, it goes on the inside, and there are, if we remove the rubber, a couple of little holes there. So we have to push a screwdriver in each side to bend this case rather than the inner mechanism. It then slides out. Somebody suggested using rubber and alcohol to get this rubber away. I didn't have any, so I tried with acetone, which of course has completely destroyed the plastic, so not a good idea. Should be, well, no, I don't think it's possible just to squeeze it. Tried squeezing it, but that doesn't work because this is not compressible, so it's got to be levered so that that slides past whatever's holding it in place. So here we have the mechanism inside. Now when I got this, I thought, simple, just a simple switch, simple on-off switch, and that's all it'll be. But no, it's got lots of components on the inside and a circuit board. Up here at the top we have the switch, which is pressed by this piece here. So when we press it, that presses the switch in, and it's a toggle switch. So once it's pressed in, it stays in until you press it again when it comes out. They've got a lovely motor on the inside of them, very nice. So what does the circuit board do? Well, complicated thing. But let's have a look at what I've done first of all. What I used to do was to take cells and connect them together, use a lithium cell, a little AA sized lithium cell, piece of wood goes at the side of it because these take two cells, and make sure that one end of the piece of wood is negative, the end of the battery is positive. When that goes in, then that replaces the two 1.5 volt alkaline cells. Of course, lithium are dangerous on their own, so what I've done here on the end, I've put on a protection circuit. So that's protected. When I charge it, it shouldn't go above 4.2 volts, and when it discharges, it shouldn't go below something like 2.8 volts. This, however, is a bit inconvenient to use, plus the fact this cell, which has come out of an electric toothbrush, still seems to work well. So I think it must have been the charging mechanism that was wrong in the toothbrush. But this one anyway works quite well, but it's only got a relatively small number of milliamp hours, so it doesn't last too long. This cell is quite good because I think that's about 300 milliamp hours. These others, which I bought with a charger, they're only about 209 milliamp hours, although they do say they're 1,200 milliamp hours. So that says it's 1,200, but actually it's about 200, which is what you'd sort of expect from cheapo Japanese cells. They weren't too expensive. Only way I could get them were by buying them with a charger, because GPO don't like cells being sent through the post. Right, so what we've got here then is a modified battery, and if I take the end off, inside here I've managed to put a lithium cell which has got about 1,000 milliamp hours, so it should last a lot longer than the little tiny ones with their 200. Once again, of course, it's got a protection PCB on it. So all I did was to cut this in half, put this extension tube on, lot of gungeon glue, and wire up to the two connections at the bottom so that my cell will charge onto it. So that's why I'm doing the video, because I did that. But doing that introduced me to this idea that there's actually a circuit board. So what's this circuit board doing? Well, if we have a look at a photo, which should be easier to see, we can see that we've got this end, we've got the motor, these two go to the motor, this one is common negative, and this one is the switched one that goes to the motor. A lot of components on here, so I sort of traced it out onto a piece of greaseproof paper and then went down to get the circuit diagram down here at the bottom. Now the components on here aren't actually marked, so what these are I've no idea. I assume that which is drawn, I think, the wrong way around there. Is it? Yeah, no, it's not drawn the wrong way around, it just appears to be on the, it doesn't look like a PNP transistor. The arrow's up the top, there's the line down, then this is coming down here into the motor to drive the motor. So whenever the base of this goes 0 volts, then it will switch this on and the motor will turn. Yeah, right. But what's going on? Now this component over here had me confused. I can only think that it's a sort of NAND gate, so that when both its inputs are low, no, I don't think that works. Anyway, when the inputs change, the output goes low, and it must have an open collector output because it's got resistors which can alter its output. The interesting thing is that the switch here connects into this side of it. So what it's got is, it's got the positive coming in this side and then through this resistor, positive here. Interesting, can't really understand why it's there. The rest of the, well, part more of the circuit's interesting in as much as it comes down here into this resistor here, and there's a capacitor. So I assume what happens, turn on, this capacitor acts as if it isn't there, that goes into whatever this is, and this then pulls this line high so that what it won't switch on until this capacitor is charged. So therefore I assume this is some sort of debounce circuit, stopping it come on until we've got rid of the bounce. This bit at the other side though, wow, this is a little bit more complicated. Looks at the output of this PNP transistor, or the input to the motor, whichever you want to consider. It then has a couple of capacitors which presumably charge up and discharge depending upon the current that's flowing down through the motor. Don't really understand that one. Well, I don't really understand any of the circuit, can't find any of the components anywhere, but it made it interesting to look at. When I'd done that, then what I did was to try and see if I can work out what it does. Well, to start with, I started putting variable voltages into the things and find it just sort of works at 1.3 volts with about 90 milliamps, and the output voltage is going to be something like 0.8 of a volt. As I increase it, this is the line that goes into the final PNP transistor. So what I've done is to connect onto this line here so I can look at the base of this transistor. That's what the bottom line is, and the top line is the voltage into the motor. So we come down, and this all seems pretty reasonable, not too much trouble. 2.1 volts, not too much trouble. The voltage into the motor's gone up to about 1.77 red on a meter. At 2.2 volts, it's 1.9 volts into the motor, into the motor. But then something happens. Between 2.2 and 2.3 volts, we suddenly start getting pulse width modulation. And that then means that the motor only gets 2 volts. Even though I'm putting 2.3 onto the supply, it only gets 2 volts. This gets better. As we increase the voltage, we can start seeing that this is the red line is into the transistor's base, and the blue line is the motor. And as we increase the voltage, this switches off for a period. And I've tried this with the battery. That was with the battery, and that's with the power supply. So I don't think it's my power supply that's changing anything. It just seems to be the battery. Just seems to be the circuit that's doing this. And if we increase the voltage here, we've gone up to 2.9 volts, and we can see that the time it's off is even greater, but the voltage to the motor stays the same at 2 volts, the average voltage, because of course it's switching on and off very fast. I think I calculated it about 250 hertz, something like that. And then even if we go up to the 3.5, we've even less time for it to be on, and at 3.9 volts, then it's still 2 volts. It's only on for a fraction of the time, but it's still giving me only 2 volts into the motor. So what does this mean? This means then that I should be okay with my lithium cell, even though this is designed for 3 volts to 1.5 alkaline cells. It should be alright on 3.9, and it shouldn't interfere with the motor or destroy the motor, thanks to that clever circuitry. What I did do though, what I managed to do to start with, was to blow one of these up, destroy it somehow. I assumed that this was an NPN transistor, and I've changed it for a through-hole one because I didn't have a surface mount, but that doesn't seem to have done anything. I suspect now that it's this little chip here, which I think is like an AND gate or some sort of logic gate that gets both positive here and here, and then gives the output out here. But what it is, no idea, can't replace it, so this is dead. I've destroyed it. Oh, heartbreak. But never mind. It's one of the tragedies of life that I can destroy things. I can take this motor out though, because these motors then at 2 volts are going to be very useful for putting into my gearboxes. These sort of gearboxes, it's the same sort of size but longer as a 130 motor. So I'll put it into a gearbox and see what happens. See if I can get more power out of my gearboxes. So it's an ill wind, and we've got to make the most of what we've got. Just very sad that it blew up the other one. Anyway, so that's it for now. So it's bye now. Bye.